So good evening to all of you. Today we are going to study Dalton's law of partial pressure. See, in Dalton's law of partial pressure, it is like this. Suppose if we have three different containers having equal volume. In these three containers, what you are saying, they have the equal volume, all the conditions are equal. In first container, we are going to fill up one gas, let us call it gas A. Let us call it gas A. Okay? And in second container, we are going to fill gas B. And in third container, we are going to fill gas A and B, keeping their quantity same as it was filled earlier independently. As it was filled earlier. Now, there is a gadget called manometer is attached over here. Manometer measures the pressure exerted by this gas. Okay, what happens over here? In manometer, it is actually filled up with mercury, and because the pressure exerted by the gas, the height of mercury changes according to the pressure. According to the pressure. And how do we measure that? We need to find out the difference of height between these two levels. Okay, and that pressure, actually, we know 1 atmosphere is equal to 76 millimeter height of mercury. Same way, they find out the height of mercury over here, and that height of mercury can be converted into pressure by using formula rho Hg. Correct or not? So here they found out for gas A, the pressure in the form of mercury, it was 300 millimeter. It was 300 millimeter. And that pressure is known as the partial pressure of gas A. That pressure is known as partial pressure of gas A. Similarly, when they found out for another gas, gas P, the partial pressure was Pb and its value was equal to 400 millimeter mercury. And when they combined both the gases in a mixture, total pressure which was found equal to 700 millimeter mercury, which is equal to 300 plus 400. Correct or not? Are you getting it? So what does Dalton's law of pressure say? Dalton's law of pressure, it talks about that if you have individual pressure, individual gases filled up, then what are the partial pressure it has, and when you combine them, the total pressure will be always equal to the sum of their individual pressure. That's what we can see it over here. The total pressure exerted by the mixture of the non-reactive gases, by the they are supposed to be non-reactive gases, is equal to the sum of partial pressure of individual. Is this understood? I want you to read that full topic. Okay, by mistake I have said something over here. It's not 76 millimeter, it's 76 centimeter, and it is supposed to be 760 milliliter of mercury. But ultimately it's the same. Now, we have studied till here. So if we have a container, then P will be equal to Pa plus Pb. Now what happens sometimes when we do experiment, in that experiment what are we going to do? You see, if we are doing an experiment over here, let's say during this experiment gas is produced, but that gas we do not directly collect. We collect it by using downward displacement of water. We studied about this kind of experiment earlier. Suppose here water is there. So in this water, Okay. See, I was talking to you about this kind of experiment where the gas is produced and that gas is not directly collected, but suppose gas is passing from here. We collect it by using downward displacement of water, and gas is collected over here. And as gas is collected, it's getting collected actually. At that time, water, okay, it goes down. We call it downward displacement of water, and we are collecting the gas over here. We have done that. At that time, the pressure which we measure over here, we do by mistake take it as the pressure of gas, but that is not actually pressure of gas. Let me explain. Suppose हम यहाँ पे ऑक्सीजन गैस प्रोड्यूस कर रहे हैं, तो यहाँ पे जो प्रेशर आ रहा है, that is the P total, and that pressure is basically pressure of oxygen gas plus pressure of water vapor, because last time we talked about it कि भाई हर एक टेम्परेचर पे वाटर वेपर तो एग्जिस्ट होगा, तो यहाँ पे थोड़ा सा वाटर वेपर भी रहेगा. So this pressure is basically total pressure of PO2 and PH2. If we want the pressure of the dry oxygen gas, we need to do very simple thing. PO2 equals to P total minus PH2. Suppose हमारे पास एक कंटेनर में हमने, okay, let's say, okay, हमने एक गैस फिलअप कर रखा है, okay, और इसका मोल्स हमने N1 क्वांटिटी रखा, गैस 1. क्या क्या लिया हुआ है? N1 क्वांटिटी. लेट्स से कि इसका वॉल्यूम हम फिक्स करेंगे, इसको चेंज नहीं करने वाले, चाहे दूसरे गैस भी इसके अंदर रहे तो यही कंटेनर के अंदर रखेंगे. जब उसका वॉल्यूम वी आर गोइंग टू गिव कांस्टेंट. ऑब्वियसली लेट्स से टेंपरेचर कांस्टेंट रखेंगे एंड R is constant, we know that R is constant. तो फर्स्ट गैस जिसकी क्वांटिटी हमने N1 ली, तो उसका प्रेशर कितना होगा? P1. उसका प्रेशर कितना होगा? P1. And we know this P1V equals to N1 RT, and therefore P1 equals to N1 RT by V. Are you following? समझ आ रहा है आपको? Now इसी कंटेनर के अंदर ओके इसको खाली कर देंगे और दूसरा गैस डालेंगे. लेट्स से हमने गैस 2 डाला, लेकिन इस बार तो वॉल्यूम तो सेम ही रहने वाला है, टेम्परेचर सेम रखा, आर सेम रखा. N2 क्वांटिटी गैस डाला, तो उसके लिए प्रेशर कितना आएगा? P2. तो उसका फॉर्मूला क्या आएगा? P2 इक्वल्स टू N2RT बाई V. एंड सिमिलरली सपोज थर्ड गैस डाल रहे हैं, देन P3 इक्वल्स टू N3RT बाई V. हमने तीनों को बारी बार अलग अलग करके डाला, इसलिए हमको अलग अलग प्रेशर मिला. बराबर है कहीं आपको समझना है? नाउ सपोज इन तीनों को एक साथ, तो आपको P टोटल मिलेगा, एंड P टोटल अकॉर्डिंग टू डाल्टन्स पार्शियल प्रेशर लॉ will be equal to P1 plus P2 plus P3. करेक्ट है ना? जानिए आप बोला. What is P1 bar? N1 RT by V plus N2 RT by V plus N3 RT by V. If we take RT by V common, then it will be N1 plus N2 plus N3. बराबर है आपको समझना. बट N1 plus N2 plus N3, can I write N total RT by V? What we are getting? P total equals to N total RT by V. उसको साइड में रख देते. Now we have 4 equations. Equation number 1, 2, 3 and 4. What do we see over here? We see a very simple relationship. देखो इसको मैं यूज करके certain relationship लेके आऊँगा. By let me extend my image. By taking a ratio of 1 by 3, equation 1 by 4, sorry, equation 1 by equation 4. That means equation 1 है ये P1 upon P total, आपको क्या मिलेगा? N1 RT by V upon N total RT by V. If we cancel this 2, RT by V, RT by V. Numerator and denominator they have the same terms, so it will get cancelled. So therefore, P1 upon P total equals to N1 by N total. But we have learnt earlier, N1 by N total is known as the mole fraction of gas 1. First semester we have learnt about this. That is X1. Therefore, P1 equals to X1 into P total. Correct or not? Similarly, P2 equals to X2 into P total and P3 equals to X3 into P total. Am I right? Are you following me? What's the use of this equation? If you know the total pressure, P total अगर आपको पता है, अगर आपके पास mixture of gases है, and if you know the total pressure of that gas, and if you know the individual mole fraction, then you can find out the pressure individually exerted by each gas. P1 find कर सकते हो, P2 find कर सकते हो, P3 find कर सकते हो. Am I right? Are you following me? आपको तो समझ में आ रहा है? ये इसका use. And similar concept can be applied if we know the percentage volume of each gas. For an example, for gas it is V1 percentage, for gas 2 it is V2 percentage, and for gas 3 is V3 percentage. Total container में कितना percentage gas है? Then we can apply the same principle, and P1 will be equal to V1 percentage upon 100 multiplied by P total. Similarly, P2 equals to and P3 equals to. Is that understood? That's the application of Dalton's partial pressure law. Are you following me? So, you people read the following paragraph till that numerical class. आप लोग पढ़ाई करो.